this episode, we shift from day-to-day security operations into a place where many of the biggest security wins actually happen long before any alert fires: the software development lifecycle, SDLC. Beginners often picture security as something that happens after software exists, like scanning for bugs or reacting to incidents. But a huge amount of risk is shaped at the moment decisions are made about what the software should do and how it should be built. When security is bolted on at the end, teams are forced into emergency fixes, awkward workarounds, and rushed decisions under pressure. When security is embedded early, it becomes part of normal planning and design, which tends to be cheaper, calmer, and more effective. Two of the most important ways to embed security without turning development into a slow, painful process are security requirements and design reviews. Security requirements define what protections the software must provide, and design reviews evaluate whether the planned architecture is likely to meet those requirements. Our goal here is to explain what those ideas mean, why they matter, and how to approach them in a way that makes security real for beginners without diving into tool-specific implementation details. A good starting point is to understand what the SDLC actually represents, because it is not just coding, and security cannot be limited to coding either. The SDLC is the full sequence of activities that takes an idea and turns it into software that people rely on, including planning, designing, building, testing, releasing, and maintaining. Each stage involves decisions that either reduce or increase risk, and the earlier the decision, the more powerful it is because it shapes everything downstream. For example, choosing how users log in is a design decision, and if that design is weak, no amount of last-minute testing will truly fix it without major disruption. Beginners sometimes assume that security is a checklist you run right before launch, but security is more like a set of constraints and expectations that guide choices throughout the cycle. When you embed security, you aim to prevent entire classes of vulnerabilities rather than chasing individual bugs after they appear. This is why security requirements and design reviews are so valuable. They shift security from reactive fixing to proactive shaping. In a mature organization, these activities are not separate from development. They are part of what good development means. Security requirements are often misunderstood because people confuse them with generic statements like "be secure," which are not requirements at all. A real requirement is specific enough that you can tell whether you met it, and it is tied to a risk that matters to the business and to users. For example, a requirement might say that sensitive data must be protected in storage and in transit, or that only certain roles may perform high-impact actions, or that security events must be recorded for later review. Even when you keep the wording high level, a requirement must still create an observable expectation, such as access decisions are enforced consistently or authentication uses a strong method. Beginners should recognize that security requirements are not about perfection. They are about making security needs explicit so they are not forgotten during busy development. They also create alignment, because developers, testers, and stakeholders can discuss trade-offs using shared expectations rather than vague fear. When requirements are missing, security becomes a series of surprises discovered late, and late surprises cause costly rework and conflict. When requirements are present, security becomes part of planned work, which improves both outcomes and team relationships. A practical way to develop security requirements is to start from assets and impact, because you want requirements that protect what matters most. An asset could be user accounts, payment information, health data, or even the availability of a service that people rely on. Impact could be financial loss, privacy harm, service disruption, or reputational damage. Once you know what you are protecting, you can define requirements that reduce the most likely and most damaging risks. Beginners often want a universal list of security requirements, but the better approach is to have a core set that applies broadly, plus additional requirements that apply when certain assets or features are present. For example, a system that handles sensitive personal data needs stronger privacy and access controls than a system that displays public information. Requirements should also reflect realistic operational needs, like the ability to recover from mistakes, because security is not only about blocking attackers, it is also about making the system resilient. By tying requirements to assets and impact, you avoid writing requirements that are technically impressive but irrelevant. This asset-driven mindset also makes design reviews more effective because reviewers can focus on whether the design protects what actually matters. Design reviews are the second major ingredient, and they exist because the structure of a system determines its security properties. A design review is a structured conversation that evaluates the planned architecture before the software is fully built, so problems can be addressed when changes are still relatively inexpensive. Beginners sometimes imagine design reviews as a gate where security people say no, but a good review is more like a collaborative risk check where people ask, does this design make sense for what we are trying to protect? A review typically considers how data flows, where trust boundaries exist, how users and services authenticate, how access decisions are enforced, and how the system will be monitored and maintained. You do not need to know advanced architecture diagrams to grasp the core idea. Designs create paths for data and actions, and attackers look for weak spots along those paths. If the design assumes trust where trust is not warranted, vulnerabilities will appear later no matter how careful the coding is. Design reviews help you catch those assumptions early, when you can still adjust the plan rather than patching after release. One of the most valuable outcomes of a design review is identifying where the system crosses trust boundaries, because trust boundaries are where security controls must be strongest. A trust boundary is any point where data or requests move from a less trusted place to a more trusted place, such as from the internet into an internal service, or from a normal user role into an administrative role. Beginners can think of it like doors in a building. Doors exist because you do not want every hallway to lead into every room without restriction. In software, trust boundaries require authentication, authorization, input validation, and careful handling of sensitive data. A design review asks whether those boundaries are recognized and whether controls are placed at the right points. It also asks whether the design creates unintended shortcuts, like a component that can be reached without proper checks. This is a place where simple questions can prevent major problems, such as asking which component decides whether a user is allowed to do something and how that decision is enforced consistently. When a design review makes trust boundaries explicit, it becomes easier for developers to build the right controls because the plan is clear. That clarity also improves testing later because testers know what security behaviors must be verified. Embedding security requirements and design reviews into the SDLC is less about adding extra meetings and more about making them part of existing work rhythms. For example, requirements should be captured when features are defined, not as a separate security document that nobody reads. Design reviews should happen when the design is still fluid, not after the system is already built and the team is emotionally attached to decisions. Beginners should notice that timing matters, because security feedback that arrives too late feels like obstruction, while security feedback that arrives early feels like helpful guidance. Another key idea is that security work should be scoped appropriately, because not every change needs the same depth of review. Small low-risk changes might require only a quick check, while high-impact changes, like new authentication flows or new data handling, deserve a deeper review. When you scale security effort based on risk, you protect delivery speed while still protecting what matters. This risk-based embedding is what keeps security from becoming a blanket slowdown. It also makes security feel fair and rational, which improves cooperation across teams. A common misconception is that security requirements are only about technical controls, but many of the most important requirements involve operational behaviors. For example, if you cannot tell what happened during an incident because events are not recorded, then your system is hard to defend even if the code is clean. Another operational requirement might involve having safe ways to change access without breaking the system, or having recovery options when something goes wrong. Design reviews can surface these needs by asking how the system will be monitored, how secrets will be handled, and how changes will be deployed safely. Beginners should understand that security is not only about blocking bad actions, it is also about enabling safe operations under stress. Systems that are hard to operate securely tend to accumulate risky shortcuts over time. When you embed operational requirements and evaluate them during design, you reduce the chance that the team will have to improvise later. This also supports long-term security because maintenance is part of the SDLC, and security problems often appear during rushed maintenance. A design that anticipates operations is usually more secure than one that assumes perfect conditions. Another misconception is that design reviews require a security expert who knows everything. But the most effective reviews often come from asking clear, basic questions consistently. Questions like what data is sensitive, who is allowed to do what happens when authentication fails, and what logs exist can reveal large gaps without any advanced jargon. Beginners should realize that security review is a skill you can build, and it starts with curiosity and a structured mindset. A design review is also not about finding every possible vulnerability, because that would be unrealistic, but about catching risky assumptions and missing controls before they become expensive. A good review also documents decisions, because those decisions become requirements for implementation and future maintenance. Documentation prevents confusion later when new team members ask why a control exists or why a certain architecture choice was made. It also supports accountability, because people can trace how security requirements were considered and addressed. When reviews are structured and repeatable, they become a normal part of building quality software. Embedding security also means handling trade-offs honestly, because sometimes a security requirement conflicts with usability, cost, or time. The goal is not to pretend trade-offs do not exist, but to make them explicit and decide consciously rather than accidentally. Requirements help here because they define what must be protected, and design reviews help because they reveal options for meeting requirements in different ways. Beginners should understand that a requirement can sometimes be met through multiple designs, and choosing among them involves understanding risk. For example, you might reduce risk by limiting access, by adding verification steps, or by isolating sensitive components, and each choice has different impacts. A mature process includes a way to record accepted risk when a requirement cannot be fully met, because pretending everything is perfect leads to surprises later. Design reviews are a natural place to discuss these trade-offs because everyone involved can see the architecture and the consequences. When trade-offs are handled early, delivery is smoother because the team is not blindsided near release. This approach also improves trust because security is seen as a partner in making informed decisions rather than as a last-minute obstacle. Over time, security requirements and design reviews also create a culture of building secure systems by default because people internalize patterns that work. Developers learn to think about trust boundaries, data handling, and access control as normal design considerations rather than special security tasks. Product and engineering leaders learn to ask security questions early, which leads to fewer late-stage surprises. The organization also builds reusable security requirements, meaning lessons learned from one project can guide the next, saving time while improving consistency. Beginners should see that this is how security scales, not by hiring an army of reviewers for every feature, but by building habits and shared expectations that spread across teams. Design reviews also produce a record of architecture decisions, which is valuable during incidents and audits because it explains why the system behaves the way it does. When you embed these practices, security becomes a property of how work is done, not a separate step. That is one of the most important maturity shifts in modern cybersecurity. When you step back, securing the SDLC through embedded security requirements and design reviews is about moving security left in time, meaning earlier in the life of a feature where changes are easier and outcomes are better. Security requirements make expectations explicit, measurable, and tied to real assets and impacts, so security needs are not forgotten or discovered too late. Design reviews evaluate whether the planned architecture can meet those requirements, with special focus on trust boundaries, data flows, access control, and operational realities. Embedding these practices into normal planning and design rhythms keeps them lightweight and cooperative, especially when effort is scaled based on risk. They also help teams handle trade-offs honestly and document decisions so the organization learns and improves over time. For a beginner, the most important takeaway is that secure software is not the result of one final test, but the result of many early decisions guided by clear requirements and thoughtful design checks. When you build those habits into the SDLC, you reduce the number of emergencies later and increase the chance that security feels like a natural part of quality engineering rather than an after-the-fact scramble.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.